Hello, good morning, everyone. Welcome to another episode of Xa Talk Show. So today we're gonna code Emacs Lisp. We are going to code multiple languages: Golang, Emacs Lisp. That's today, but this is in a series of building a hash table, also known as map or dictionary, in Golang, in Emacs Lisp, in Wolfram language, and in, let's say, PowerShell. So, and maybe in Python. So we started yesterday. So yesterday we built a hash table, not just building a hash table, but also traverse a directory. The directory is like 40,000 files. Okay, so so traverse a directory of 40,000 files or more, make them into a hash table. So we're gonna do that in several languages, and then we're gonna go through the hash table for each key to check if it exists. This is for the purpose of checking the file exists as a replacement, and we're gonna test the speed of all these languages. Okay, and language comparison, comparative language study. So we can see, for example, the Go code yesterday, let's see, this is quite long. It's like 30 lines just to go through a directory and build a hash table. Also, there's a condition. Go through a directory, but if the file directory name is one of these given, then omit it. So this is important part, because with this, then there's some trick in depending on the languages. Some languages make it so easy, some languages not so much. So yesterday I tried to do this in Wolfram language, one single line, but failed. Well, partly because I'm not too familiar with this usage of Wolfram language. So anyway, so let's build this. So let's build a hash table. I just discovered there's something wrong here. Okay, so this is this talk show, and this is yesterday. Open it. Go to the bottom. This is placed in the wrong position. This nav panel. Okay, where's the main? Oh yeah. So this topic box should be inside the main. That is why you are seeing, so now, formatted outside of it. So refresh, now it's good. Okay, so let's start. So today, yesterday, you can watch yesterday, we built Golang. Today, let's do Emacs Lisp. Emacs Lisp, I've done it 1,000 times, so it should be easy. So are we ready? Yes. Are you guys ready? So if you are watching this offline, play at 1.5 speed. Okay, so yeah, so we're gonna start to write Emacs Lisp code. Okay, so the task is specified here. Okay, let's copy it. Okay, so this is today. Yeah, so let's start Emacs Lisp. Okay, and start and paste it. So that's the documentation. Create a hash table. Each key is a full file path of a dir, including subdirectory, but excluding given list of the names. Then test speed by go through the hash table, check each key exists. Okay, then do this in Golang and stuff. Okay, so if you have comments, questions, say it. Okay, do you prefer Windows, Linux? That question being asked 1 million times, and I've answered 1 million times. Just search my YouTube. Okay, so build a hash table. So there are two things involved. First of all, you want to work a directory, then build a hash table. So work directory, how do you do that? That's here. You can search for it, Emacs Lisp tutorial. So we want all subdirectories too. So here is the code, here's the documentation, and let's just copy it. Okay, so we go through walk a directory, then build hash table. Okay, now there are some directories we don't want, right? So let's copy exactly what is the directory should be excluded. Okay, this is important part. So there. Okay, so first of all, write documentation first. Okay, so exclude this. So this is Golang code. So this make it Emacs Lisp. So this is gonna be a list. Okay, so wait. So remove the comma, because in list you don't want comma. Okay, so yeah, you can do that, or actually just okay, so let's do that, and set a variable, and skip the, okay, something like that. Skip the equals to that. Okay, that's a Emacs Lisp way. Now traverse the directory. Now first of all, what's the input? So input. So you need the input. For now, let's go to talk show page for testing. So that it's not too long. So input is just talk show. Okay, yeah. So now build a hash table. So okay, so that is this function directory files exclusively. We need to go fast. Comments. Okay, so yeah, so the pink window shows all my command calls and keystrokes. Okay, so directory files recursively, and here is the input path. Okay, now input let's name it X input because that makes it easier to complete. So recursively go into this directory. Then what is the file name extension? I don't think we care. We want all files. So go back to Emacs Lisp. So what is the documentation? The regular expression. The regular expression return names that contains the pattern. Okay. Now you see, the Emacs directory traverse function is not very good, okay, because I've used it, tens of times, like for 20 years. It's not very good. It's not very flexible, and it's fairly slow. It's much slower than other languages. For example, one of the example is that suppose you want to list all directories that are empty. So you have lots of directories, you want to, list all directories that's empty in a directory. That, try to write that. You think it's just one line, but that's gonna be fairly complicated, okay? I can show you the code, okay? I can quickly show you it, okay? So delete list empty, okay? So wait, where is it? List empty directory. Okay, so you jump to the source code. So this here is how you write it. Okay, this okay, this code actually not so trivial. Okay, so let's get back to what we want to do. So input directory, then here's the regular expression. Now you can pass a dot that just match anything, but I remember there is something special, okay? This you can just say a dot that matches anything. So, but I remember there's something special, okay? But anyway, let's push on. So what's the next argument? And also, Emacs Lisp do not, you have a whole bunch of arguments, ordered arguments. So it's very confusing which one is which. So anyway, directory regular expression optional include directories. Do we want to include directories? Yes. Okay. Yes. Then what's the next? Then directory predicate. Okay, so this part is the directory predicate. Okay, so directory predicate in this case, filter. Okay, Neo dive into all subdirectories. Okay, yeah, so this part, right, so this part is actually, if it's a directory, ignore it. Okay, we don't want to, this will return a list, so we don't want to include directories. Okay, so the regular expression include directories. The regular expression include directories. Neo. Okay. Now the predicate, which is a function that filters. Okay, so the function is passed a subdirectory full path. Okay, if f returns true, dive into that. Otherwise, no. Okay, the function is passed the subject. So what do we have? Not string match. So this is skipping or dot files. Now in our case, what we want to skip is we want to skip this. So the function will be if that matches any of that, then skip. Okay. Yeah, I've written this somewhere before. Mathematics teacher would be a cool high school teacher. Okay, so I've written this before, so why don't we just look at our code? So save us some time. So yeah, so why don't we do that? So go to my Ep file, just Ep file, that is all my personal init. So now just search for that, you'll find. I'll kind of find it. Okay, so site external doc. Okay. What is this? Is old code. I don't want that one. So what? So I'll find the external. Okay, so I have it there. Describe variable. So this is in package find. Okay, so search for that. Okay, so this is a function I wrote. Find, ignore the true root path. So return true if one of the find the ignore rejects list. Yeah, okay, it's getting complicated. Let's copy the file path here. Okay. Let's paste that. So find the ignore regular expression list. So this is actually a list of expression. Okay, rejects match, case sensitive. Okay, so and the function that actually does that is this. Okay, and what are the others? And here, this one is filtered by path regular expression. Okay, so this, you see, it becomes slightly complicated. So this is Emacs Lisp case. So what? So anyway, let's. Okay, let me just do this. Okay. So this is input the. Let's skip the. Okay, so and what is our solution? Now these are exact directory names you want to skip. Okay, now if you want to turn it, if you want to implement them as a list of regular expressions, you can. But the specification by our problem is exact file path names. Okay, so so let's see. This will return a list of the names and what this lambda exactly. Pass a subdirectory full path. Passed a subdirectory full path. What? That doesn't make sense. Okay, this part I need to elaborate, because exactly what is a subdirectory full path? I suppose it means the full path of a directory, but minus the root, something like that. But we can test it here. Okay, so right now it's skipping dot. Okay, so we can just say message printed. Let's just say x is x. Okay, it's not that. Okay, so that is that, and this, ignore it, put it here, and here also remove it. So here is our code. Okay, here is our code. Here's our code. We can run it. Okay, so and we'll print a bunch. Then we will know exactly what is passed there. Okay, run it. Something is wrong. It's not running. Why is that? What's going on? Oh, it did print. Okay, it did print. So you can see. Oh, okay. It's printing the full path. Okay, now that's good. Okay, so now you need just to extract. So given a full path, how do you get the base name? Okay, let's run it again. Show. Okay, here's an example, so you can see. Let's go to talk show. Let's go to talk show. Go to the directory, so you can see. You see, there's I and IPC directories subdir. So these are a bunch of, okay, these are audio files, and these are image files, and whatnot. That's one of the advent of code problem. So you see, we got these subdirectories. Okay, we got those subdirectories, and let's paste it there, and then we can document this my tutorial. Okay, so this is confusing. Let's just name it, just f is past full path. Okay, and also without the ending slash. because normally Emacs always prints, ending slash, okay? But without the ending slash. So to the browser, refresh. So this is critical because when you process directories, I do this in so many languages in the past 20 years. Some use backslash, some use forward slash, and also for a directory, you have to think about whether the directory ends in a slash or not. Because you need to know, because then when you want to join the file or get the parent directory, you want to join two paths, you want to make sure there's only one slash. So the detail about exactly what it returns, this function takes is important, okay? So, but now we clarify it with an example, okay? Good. So that is what the function get, okay? Now back to our code. So this is a sample. So now we know that we can simply get the file path, okay? File path, file name directory. Yeah, we can simply do that. So for example, okay, so that is the file path. Put it there and remove that and evaluate it. You see now that is incorrect. So you see, okay, so what you want is file name. Yeah, you see it's misleading. So what you want is that's what we want, okay? File name non-directory. So here x, now you get the non-directory, which is the I part. Then you want to see if it matches any one of those, okay? So here, here is another problem. If it matches, return true, okay? In that case, we can use Emacs Lisp. Let's go to our talk show. Okay, Hashtable. So that's Golang. That's file path functions. Okay, delete the Golang stuff. Okay, delete the Golang stuff. Okay, so file path functions, and what we want the so we want list functions, okay? So Lisp basics, go to list structure, sequences, yes, there. So we want some and every, okay? Sequence some and sequence every. Yeah, as soon as you found the item, return it. Don't continue, because this would be efficient. Okay, so copy that code, but copy the file path here first. Make the file path there, so go there, then copy the code. Now go to our code. So now here is what we want. Okay, so let's let's be very careful here. Okay, so lambda here is a sample x. Okay, and this is a string, of course. Okay, then this part we will use. Okay, now file name non-directory, so we're gonna do sequence sum. That's right, is that right? Yeah, that's in. Okay, so now we're gonna do sequence sum. Okay, now sequence sum lambda again, nested lambda. Now this x will be y. Let's just change it to y. Okay, and then sequence sum. So let's use a let here. Okay, let the name. Okay, let x the name, just show the name, no nothing. Okay, so that will be that. Okay, that sets the directory name. Okay, this part we don't care. Okay, we don't care. Then sequence sum, move inside. Pretty fine, fantastic. Okay, so now the name is just a single I, for example. Now sequence sum lambda yy. Now if so, the sequence is going to be this sequence s x skip the. Okay, let's change it. What? Skip the list. The ignore list. Okay, let's change. Because naming is very important. So this is gonna be x the names ignore list. Okay, make it, so people read it, we'll know exactly these are not, because in this kind of thing, sometimes you want, sometimes you have a list of regular expressions, sometimes you have, a list of names, but you mean containing that part. So any directory name contains that, ignore it. But sometimes you want exact directory name match. If exactly match, then ignore it. For example, git. If a directory name is exactly .git, you want to ignore it. But not if the directory name is something .git. So this is kind of confusing. Okay, so anyway, so let's go back here. So if the current name, so wait, so okay, and we're gonna use string equal. Okay, if string equal the name is one of these, yy, then return true, right? Sequence sum, yeah. Then return true. That means ignore it. Okay, so what is the logic? Sometimes they what is the work directory? Okay, there, work directory, predicate function, function. If function return true, dive into that directory. Okay, so if it matches this ignore, then nil, otherwise true. Okay, so let's see. If string equals the current name matches one of these ignored name, then return nil, otherwise return true. Okay, carefully. So this can be one line. Okay, kind of. Okay, so that is good. So I'm sure prettify the code. Okay, so recursively input the dot means no filter, but there is a more efficient way. So this is the complexity of the Emacs Lisp directory walk function. Okay, so let's see the documentation. So you see regular expression there. It's not here, but I remember maybe it's in this. Yeah, it's here. Directory files. The return path may include the Unix dot, means the current. Okay, so that is the directory files. So to exclude them, use match regular expression. That does not match dot. Okay. Yeah, so there is this built-in variable, directory files, no dot file, regular expression. There. Okay, directory files, no dot file. This is like a hack. So describe variable, that variable. So you can see it's a built-in constant whose value is this. So this relates to directory files function. Okay, so but does not relates to directory files recursively. So you see, that's a confusing part. You need to know these details. But in our case, we don't need to worry about it. Okay, I think that's it. That's that. Then this is our code, and this we don't care. This is just okay. Let's run it. It doesn't do anything. Now you need to print it. Okay, so now you need to oh, did you actually build a hash? Wait, okay, so this return you need to say okay, set file list, then that okay, then you can print file list. Okay, evaluate it, then describe variable, so you can see there it is. Okay, so you can see it's got like 2,000 files, Xahlee talk show. Okay, 2,000 files, Xahlee talk show, including image files. Now there's a problem because it went into the image directory, which is named I, but we told it not to go into image directory. So our code is incorrect. What the fuck? And also, if you want to match anything, just empty regular expression will do also, because we can try it. Describe variable, yes. Okay, but now is the problem is with the it went to the image directory. Did we have this correct? Actually, the name ignore list value is yes. Okay, so sequence lambda. Now if string equal the name yy, so let's rename ignore the. Okay, so rename yy ignore name. So if string equal the name, file name then directory. Wait, so how do you know that? So is this predicate, does this predicate always receive a directory or not? Okay, so you have to say include directories. What? So the predicate, so it's a directory predicate, so it's not just any file. So this predicate is only for directory. Okay, filter on which subdirectory to dive into. Regular expression is applied first. Okay, before the predicate sees it. Okay, so match anything, that's a regular expression. Then neo means we don't care about directories. Include directories. True means in a result include path that are directories. So false, we don't want a list of the directories. But however, we want to go into subdirectories, so that is the predicate. Have you ever seen Windows 11 before? No. What is this? So can we just evaluate the whole thing again? Describe var. Let's see it. Sequence sum. Okay, so in sequence sum returns true. Okay, so you need to actually kind of reverse this. So if string equal return neo. So we don't need the whole if. Okay, just check that. Okay, If it's equal, then nil. So as soon as there is a true exit, okay, sequence, as soon as there is true, so we want sequence every. Oh, okay, so let's path functions. So talk show path function sequence. Okay, I think sequence every is what I want. Yeah, that's right. Sequence every. Okay, not the sum. Okay, so sequence every. Sequence every. Okay, as soon as the value is false, the loop stops. Okay, so if so, we got into a confusion of Boolean values. Whether true is good or false is good. There are two levels of it. One level is within the sequence every. The other level is what its meaning in the subdirectory. So, but here, so if string equals to ignore, if that is true, so but overall this needs to return. So true means dive in. Okay, whether we want to dive into the directory. So that nil, so that returns nil, otherwise true. Okay, yeah, that's what we want, I'm pretty sure. Prefine the code. I think that's good. Okay, we can run the code, run it. Now, describe variable that check. Fantastic! You don't see the I directories anymore, you see? But now you have the IPC directory. We can ignore it too if we want. If we just add IPC, for example. IPC, run it, describe variable that, and you don't see the IPC directories anymore. So fantastic. So this is fantastic coding and done. Okay, very simple. Now we go into each hash table and just check. Okay, so what we do now is we go through the hash table. Okay, how do you do that? So first of all, put the code back, color, syntax color, showing browser. So that is the fruit of today. So now we go through the hash table. For each key, we check if the key exists. We do that because ultimately we want to check the file exists. But since we build a hash table, wait, did we build a hash table yet? No, not yet. Okay, let's build a hash table. We haven't built a hash table yet. Okay, so let's do it. Okay, so but we got the file list, so let's create a hash table, xtable. Okay, then okay, create a hash table. Then what to do? So the default test is equal. Does equal test string equality? Let's check. Yes, good. It's kind of confusing because in Emacs Lisp you have equal, you also have EQ, and you have string equal. You have quite a few others. And you also have the equal sign. So anyway, so equal is good. So now we want to build a hash table. So first of all, you need to go through this. Okay, map C, map C, map a function to this file list, and for each one, what to do? We hash table add. Put hash, that's right. Key will be just the file path. Value will be, we don't care, 1. Table will be xtable. Okay, now evaluate it. Fantastic. Now just print a hash table. Okay, now can we print a hash table? Clear map hash. Yeah, so you can map hash. You can also print hash table. Okay, and we got a code. Let's just use it. Why not? So format hash table. Oh well. Okay. Format, then print format hash table, xtable. Okay, format into a string, then just print. So we don't even need the format there. Okay, evaluate it, show the messages buffer. Fantastic. There it is, our hash table. Fantastic. Okay, done. Now that's it. Okay, so now we need to, the last thing to do is some timing. Like we talked before, we need to check how long does the whole thing take. Okay, so put the code back, showing browser. Okay, so we need to do timing. So for example, yesterday, let's go to yesterday. Okay, backup, close, open. Now clean up. What is this? Okay, so what is it? We don't need that. So what are we doing? Okay, go to topics box, go to yesterday's talk show, and go to Golang. Okay, this is yesterday's code. This is Golang. It's a different beast. So let's run it, see how long does it take. So this is xahlee info. You see exactly the same. Ignore list of file names. Okay, run it. First time is slow because it's going through like 20,000 files or something. Okay, time spent in 1.2 seconds. Let's run it again. Run it. Time spent in 0.1 seconds. So that including traverse the directory. Golang is more tedious. This is how you traverse the directory with this walked. Okay, then you build a hash table here. Then you print the time. So run it. 0.1 seconds. So in the Emacs, so let's print how many items in the hash table. We need to know that. Okay, so how do you print how many items in the hash table? So I don't remember. So let's go to Golang map, create map with make get value add key delete key loop. What is the count? Bad tutorial. I don't have the information. I mean, I don't have the easy to see information about how do you get the length of a hash table. So what? So that means I need to think. So Golang switch mind to Go language hash table. So what? I believe it's just count, right? Do you guys know? Interesting. I don't even have a count length of hash table. What? My tutorial is failing. Count. Okay. Interesting. I don't have that information. Okay. Let's see. Golang count map. How to count items in Go map. Len. Okay, so obviously len. Okay, so let's print len. Len x table. So run it. So first of all, it prints all of them. Let's see. So there are about 17,000 files in xahlee.info. Okay, so go to the bottom, exactly 17,004. Okay. Now you see when you print it, it takes a long time. So the timestamp needs to go before it. Okay, we don't want the timestamp there. Okay, so there. Now run it. What? Yeah, so it takes 0.1 second, not counting the time to print. Okay, so Go is pretty fast. So but there are 17 and 4 items. Okay, so that's Golang. Close, put it back, syntax correct, show in browser. Fantastic. Now back to Emacs Lisp code. Now we hope Emacs Lisp code may be better, maybe not. Okay, so but first of all, you need to compute the time information. God, I don't know how to do that. Okay, so we go to Emacs Lisp basics, search for time, print datetime. Well, okay, so you got, can we get the Unix seconds? Okay, there it is, Unix time. Close that. So set start time. Okay, something like that. What? This annoying annoying syntax for the comment. You don't want common syntax that is white space sensitive. In the case of Emacs, it is because it relies on the end of line. So what does that mean is that it stops your syntax being capable of made into one line, and or reverse it, So it's basically stops auto formatting capabilities. So whenever you have a syntax in your language that is white space dependent, it stops your programming language from being able to automatic format the code to some degree. So typically in every language, their string is always white space sensitive, obviously because when you want white space in it. But so almost all languages has this issue. So, but however, if we exclude strings, then we have the common issue. So for most languages, actually vast majority of industrial programming idiots, C, C++, Python especially, Ruby, Bash, PowerShell, they all basically have a common syntax that is dependent on the end of line, which is a white space. So that means you cannot just like compact your code, like you cannot make it this into a whole line. It won't, because then it fucks up, the whole thing becomes a comment undo. So, but if you have a language that doesn't, whose comment does not depend on end of line, such as Pascal, Wolfram language, Haskell, and others, then you don't have this problem. You don't, and HTML, because their comment is matched. In the case of Wolfram, it's paren and star, and also for Pascal, it's angle brackets with a dash inside, and for HTML it's angle bracket and 2 dash, something like that. So, but anyway, if you have matched comment that does not depend on the line ending, then your programming language maintains the automatic formatting ability. So that is an interesting issue, okay, about that. So anyway, let's go back to this. So we got the time. Let's evaluate it. Yeah, we got the time in seconds. Then go to the bottom. So it should be pretty simple. So before we print, we want to say end time. Okay, so end time. Okay, then you just say print start time minus, you cannot minus in Lisp, so okay, then time spent. Okay, that should print it. So let's run it. Okay, yeah, let's right. Wrong argument, number or marker. Okay, so this got time. Okay, you need to number. Okay, so string to number. Knowing string to number. Okay, run it. Okay, so now we got the whole hash table here, and do we have time? So there's too many of it. Is score off the buffer. So well, then we have to create a buffer. We have to print. We cannot use messages. We have to print into a dedicated buffer. So this is like entirely boring for you guys, I guess. Because too much technical details now. Okay, so let's end time, start time. So we need to create. Okay, so let's go to buffer. When your program is complicated, and especially when you are printing thousands. In this case, like what was it? 17,000, 1,700 lines. You do not want to print to the messages buffer. You want to create a dedicated buffer, because you can see the messages buffer just scrolled off. A maximum of 1,000 lines. It just scroll off. So you want to. So here is when we want to. So let's. Lisp print datetime, and we want to go to buffer. Okay, so that would be Emacs Lisp buffer and files. Okay, so buffer functions. So we want to create the buffer. Yeah, usually we want to use this. Okay, I'm not going to explain because it's gets complicated. Okay, so but now. So now actually let's create a let. Okay, so because now it's getting big. Okay, so new buffer, new buff. Okay, we declare a variable new buff, and this buffer will be xtable output. Okay, let's name that. And by convention, Emacs generated buffer has a name of star before and end at the end. Okay, so now we create a new buffer, and okay, so then you can move this inside, and then you can say with output to buffer, with out to buffer. Okay, wait, there's a command with output to buffer. Okay, so now you need to go to print. Okay, go to print. Print output. Okay, print to buffer print. So we can use with output to temp buffer. With output to temp buffer. What? So I guess I don't have a brief for it. Okay, so buffer name will be new buff. Then buffer rest body. Okay, so rest body. So what you want to do is we want to print that. Okay, and not messages. Okay, so we want to print okay, and also okay, this function yeah, well, okay, so this function, okay, leave it there. So but print, prettify it. Okay, redundant. Okay, so kind of like that. And let's add let's add lexical binding. Okay, because that I think makes it faster a bit. Compare it, no error, good. Okay, now can we run it? Yes. Oh, how many items in hash table? So you need to print it. Okay, so I want to know how many items in hash table. So print, and how do you find out how many items in hash table? So walk directory, file path functions, every walk directory, print hash table. Yeah, so go back. Length. Oh, actually, hash table count. Okay, so hash table count, x table. Okay, that returns whatever, put it here. Okay, so total items. Okay, and then switch to buffer. Okay, then you just say switch to buffer, new buff. Okay, okay, right. Invalid function -1. What? Print invalid function. So some. Oh, okay. So yeah, you need format there. Format that and that is inside prettify. Okay. Evaluated. Fantastic. Time spent 0. So it's even less than a fraction of a second. Total items 1604. Oh, so it's different from the Golang. The Golang is 1704. So Golang somehow got 100 more files. Well, I can see, you see, we got some Emacs backup files. So let's remove those backup files, okay? So anyway, this is the result from Emacs. It's fantastic and beautiful. Put it code back, show in browser. So this is today's result, fantastic. And yesterday's beautiful code is this Golang. But now let's go to the directory, okay? So xahlee info. So I just press the key. Press. Do you want to delete all these backup files? Yes. Okay, so not many. So why is there a difference, you know? So let's run it again. Okay, so because let's see. Because yeah, so we don't want this I here. Okay, we want to make sure they are the same. Git manual closure JS node. Okay, run it. So total items, wait, now it's 2000. Wait, why is it 2000 now? Oh yeah, because yes, 2000, 2135. Okay, now close that, put it back, syntax correct, go to yesterday's talk show. Now open the Golang file. Now make sure the skip is the same. Prefire the code and run. Okay, so in the Golang case, it's 23,000 files, so they are not exactly the same. I have to figure out why. Okay, the result is different. I have to figure out why is that exactly. Okay, but that's it for today. Thank you guys for watching. Yeah. Put the code back. Syntax correct, showing browser. Okay, bye guys. If you like my stuff, pay me. Okay, 7 people watching. So go to xahlee.info, and at the bottom you can see my Patreon gift card, Amazon gift card, or PayPal. So if you work in a corporation, just pay me 100. Thank you. So that's it. Okay, we shut down in 1 minute. So today is kind of like real life coding, because in real life coding, you got, kind of lots of complexities. I mean, compared to actual real life, today is actually pretty simple. All we want to do is actually create, walk into a directory and ignore certain directories and just create a hash table. Very simple, and print a hash table. But then we have to we spend a lot of time into, look into the technical details of this directory file recursively, in a necessarily way, because, this predicate, this regular expression gets very confusing, and whether, the backslash or slash stuff. So we looked into hash table. Then we have to write a function to print, pretty print, then file path functions, and sequence some, and sequence every. This is functional way to do things. And print time. Okay, bye guys.